Welcome, .NET friends from all over the world. It's another episode of On .NET Live, where our mission is to empower you, the .NET community, to achieve more. I'm your host, Scott Addie, joined with co-hosts Luis Quintanilla and Jeremy Likness. I'm super pumped to welcome today's guest, Christian Wenz. Christian, would you like to briefly introduce yourself?
Sure. Thank you, Scott, and hi, everyone. So I'm Christian. I've started doing professional web development about 25 plus years ago and never looked back. I've been an MVP for ASP.NET back in the days, and now I think it's just development. Again, since 2004, so I've seen a lot of different technologies, and one of the pet topics I started doing in about 2001 was web application security, thinking that it would be just, a temporary phase, that the problem would just go away and I could continue, doing web applications instead of making them secure. And here I am. Great to be here. Hi, everyone.
That sounds great. Yeah, I think just speaking from experience, security tends to be that can that we all kick down the road. We know eventually we have to deal with it, but it's never, at least for me, something I enjoyed doing. So this will be, I think, a particularly useful conversation today. I guess my first question is, where do we start with this conversation? Let's say we're building a brand new ASP.NET Core application, and we want to make sure what we're doing follows security best practices. What would you recommend?
I mean, good news first, the stack already provides protection against several risks and attacks. So, and I mean, I'm over exaggerating a little bit, but even if you have no clue what you're doing, you still will most probably end up with an application that is fairly secure. Still, of course, to have a real secure application and to be in the driver's seat with regards to security, you have to know what kind of risks you're facing, what kind of attacks exist. So awareness is key. You already mentioned, right? Security, the can we are kicking. You can't see security. I think that's one of the fundamental problems. It's like brushing your teeth, right? You don't see whether someone brushed their teeth unless they didn't do it for a long time, right? And it's similar with security. You see the lack of security when things gone bad, but you can't see the presence of security in a way. And so there are different approaches to that. And in my personal experience, I would say that again, awareness is key. Knowing what you are up against. You just mentioned you don't like security. I do like it because I can destroy things and call it work. So there are some advantages to that profession. But of course, I absolutely know what you mean. It can be really cumbersome. And I think if you're really aware of what you're up against, if you know what attacks and risks exist, and especially how they work, how things can be exploited, then you have that. You subconsciously have that ready, and you automatically write more defensive and more secure applications. And especially in the web, there's quite a good well, there are several good resources, but there's one resource that is referenced pretty often. And I mean, the web has the advantage that no matter what kind of stack you're using, there's always a common denominator, right? You have HTTP, you have a browser that's unfortunately speaks JavaScript, you might have a database that understands SQL. Basically that's it, right? And so one thing that I always find kind of useful, you have to take it with a grain of salt, but I find kind of useful is the OWASP top 10. So the OWASP is the Open Web Application Security Project. You see the homepage here, owasp.org. And they're probably the best known project, apart from many others, like a vulnerability scanner and various cheat sheets, checklists, verification standards, gatherings, meetings, documentation, etc., etc. They have as a flagship project something called the OWASP Top 10. So that's why it's the top entry here, basically in the projects list. And that's a list that's curated every 3 to 4 years, I would say. I think they aim for a shorter cadence, but basically that's what we get from experience. And that is a list of the top 10 security risks. It's not attacks, because there might be more than 10 attacks, right? But risk, everything is risk management. There might be a risk, but you might then, when you evaluate the risk, say, okay, that's really not worth protecting against. There might be risks that fall into that category, right? So you have to be aware of those risks. And so the OWASP top 10 here, it's a lot of text, but we could, if you want, look at some of those items. Is a list of 10 10 items, basically 10 buckets. So what OWASP is doing, they're using the CWE scheme, a common weakness enumeration, where every weakness has a number, and then they put a couple of them into a bucket. So because only covering 10 risks, that would be they would leave so many things out, right? And the list should be the awareness list. Basically, the premise is, you are aware of the list, you're aware of all the risks, or all the major risks that are relevant today, right? So they put a lot of things in the bucket. So for instance, actually, you may be able to make that out here, actually. So the first item, it's called broken access control, super generic term, contains 34 different of those weaknesses. Others have less, right? But basically, that's the idea how they do it. So they ask practitioners, people who do security audits or work in other areas of that field, and basically they give them their audit results. And I simplify things a little bit here. They basically say this weakness. Remember, we have this scheme where every weakness has a number that many times. It's a bit more complicated than that, but basically that is the input, and that gives us 8 out of 10 items of the OWASP top 10 list.
So
Only 8. Yeah.
I guess my as I'm listening to you describe this list, Christian, I'm wondering, I see a list of 10 items here. How are they ordered? Are they ordered in terms of like highest severity to lowest severity?
Yeah, it was pretty data driven. So they have the severity, so the impact, also the exploitability. I mean, as you know, there are different ways how you can then categorize and prioritize items. But basically, yes. So it's a completely data driven approach with basically one exception. So I mentioned that they create create 8 items for the list. But the problem is, well, I don't know if it's really a problem, but the situation is that the input is the result of past security audits of applications that have been implemented in the past. So that list is a look in the past. And of course, there could be a risk that there is an upcoming risk or an upcoming attack that is super dangerous. But since it wasn't found in last year's audit, it doesn't show up on the list, and therefore there's no awareness for that. So that's why I did a second survey and basically asking practitioners, okay, so what do you think will be an up and coming threat or an up and coming risk? And they took that again, they crunched the numbers, they compiled it, and then they added 2 more items to that list. So now we got a top 10 list. And I mean, I I find this approach pretty useful. You have to take it with a grain of salt, of course, right? Because I mean, and I'm speaking about myself here, but maybe some of you fall into the same category. A new version of C# comes out, right? And there are some new features, some syntax sugar. Don't you also sometimes have the tendency to take these new features and use them because you can, right? So like, it's new. Not everyone knows about that. I shine even more by using these features. And again, of course, I'm exaggerating a little bit. Most of the time, there's a really, really, really good reason for new features being added to the language or new features being added to a technology. But sometimes you have this bias that it's new. Not everyone knows that, so I deem this important. That, of course, could be the case with that survey as well, that people not necessarily picked what they think will be dangerous, but maybe something that's relatively new and relatively unknown. So, but again, it's an awareness list. They try to make this process. Actually, there's great documentation on the website about how they did it. Um, they try to make it as data driven and as scientific as possible, right? And I think they succeeded to a great deal. But again, their weights added, their weights with those numbers, the categorization, which falls into which bucket. Of course, that's not all objective, right? And so there could be a bias included there as well. But at least for me, the aim of that list is not, okay, people, look at that list. And if you don't have time, just look at the first 3 items because they're much more important than the remaining 7. No, that's not the case. What's in the list is, with maybe one exception, relevant, and you have to be aware of that. And of course, the things rather on the top of the list might occur more often or might pose a greater risk. But still, the list is the baseline, and you just should be aware of that. And again, the list contains risks, so they don't give you a blueprint of, hey, here's a list of 5 APIs that you have to use in ASP.NET Core, and then your applications are magically secure, right? It's not, unfortunately. But it's just supposed to create awareness. That was a long answer to a short question.
That was a good thorough answer. I'm curious, the tools that they use to actually come up with the list, do they provide those tools or that guidance so that you can turn it from guidance to here's what my actual risks are by running it on your own system?
No. So you mean the tools that generated the input for that survey?
Sure. I mean,
Yeah, no. Basically, what happened was those people turning things in were companies doing automated dynamic security scans or static security scans, or auditors that did common audits. So basically, they just said that risk that many times and
right.
that many types of applications, and sometimes which specific industry the application was in and which stack they were using. But basically, that was the input. So it was a bunch of JSON data. And that it was publicly visible, at least for the predecessor of that list back in the days. And I mean, that sounds funny if we talk about security related stuff. Back then it was Excel sheets, right? That were uploaded and then crunched. And now it's JSON. Yeah, but
So do
I
you
think they should
have
be
a,
publicly available as well.
do you have a tool outside of this that you use, or is that something you're going to go into? Is it more I have to be diligent as a developer and do these things as I'm building the app, or is there something that can help me and guide me sort of in that process?
So in my personal opinion, but again, that's my personal opinion, most of the web application security related issues come from the human factor, right? So awareness and training is paramount in my opinion. But of course, it also helps to actively look for security issues in your code as well. There are services, for instance, GitHub Security is, I think, a very common one that tries to do static code scans for typical pattern for certain attacks or for secrets that are included in plain text, right? So people put their connection string in app settings JSON and then happily upload that. So that is one aspect. There are also security scanners. Specifically, most of the time they use their apart from the static code analysis I just mentioned, they're dynamic code scanners. So they try to send malicious, or exploit payload to a running application. And there are commercial tools available for that. So when doing an audit, that's often some things I use. Also have some homegrown tools because I mean, it doesn't really matter what technology is being used, but depending on the technology, some, let's say, exploits are or vulnerabilities are more likely than others, right? Actually, OWASP also has one of these security dynamic security scanners, and it should be also one of the flagship projects. Yeah, it's the ZAD attack proxy. ZAP. And basically you, and yeah, I sound like a marketing person, right? And I'm no way affiliated, right? So please believe me, I'm not. But basically you type in the URL of your application and then, it scans your application. Works really well for traditional web applications. You have to set up a little bit more if you have a single page application, because for a single page application, so much is done using JavaScript, right? So you can't just scan documents. But yeah, so these are the tools that I use for audits, of course, but also I often work with development teams pre or post audit, which always is great fun. And sometimes when we devise a security strategy, one part of that is also doing the scanning. I have to be honest, I'm always a bit hesitant when such an automated scanning, especially dynamic code analysis, is part of the strategy. And there's a dashboard that said, okay, last night the scanner was running and it found 17 things, and I mean, quote unquote things, because when you run such a scanner, I mean, the scanner tries different payloads and then look at the replies whether the attack probably was successful or not. But there's of course no proof. So the number of false positives, so something was reported but it is not a security vulnerability, is relatively high. So that number that those automated tools give should, at least in many cases, not be used as a metric, because then often the development teams they are not really accepting that, because they maybe know, okay, we found 17 things, but 15 out of them are trivially false positives, and the two others we have to discuss them, right? But if it's part of a strategy so that the team itself looks at that but doesn't use it as a metric, like the code just got worse or just got better, but as a security is important to us, security comes first and foremost in our development process, then I do see value there. But still, I mean, even with all the great automated tooling, and the secret, of course, is not running the tools, but then, analyzing the results, still with a manual audit or by manually looking at stuff or by also knowing the code and therefore knowing what could go wrong, this just finds so many more vulnerabilities.
So Christian, as I'm looking at this list, one thing that really stands out to me is that it says broken access control has moved up from the 5th position in the list from the last time this list was created. This might actually be a good place to start. If I'm an ASP.NET Core developer, what kind of things might I look for in this category?
So what this category basically encompasses is wherever let me go a step back. I think in the predecessor, no, in the list, two lists before that, there were two items instead of this one broken access control, and one item, I don't remember the precise names, but one was unvalidated access to objects or to data, and then the other one was something like unvalidated access to functionality. So basically, either I have some resources lying around that I can access without access control, or I have some functionality that I can call without authentication. And of course, this is a super generic topic with so many things included in them. So it's tough to point at one or two things, thus ignoring the 32 others. I would like to answer this question with this. Specifically looking, of course, at our stack. So with ASP.NET Core, and I think that definitely goes back to ASP. I think even ASP.NET Web Forms, right? I mean, with things like data annotations, we already have one approach, and of course there are others, right? But one approach to have, let's say, validation rules for the data we are expecting, right? And broken access control, at least some of those risks involved there, basically mean we have an endpoint or a method or whatever, and that receives data, usually by the client or by the attacker in that case. And the data is not what we expect, more than we expect, less than we expect, or just garbled or invalid data. And data validation just helps a lot here. It sounds super trivial and super simple. I mean, data validation for web applications exists since there were web applications, right? I mean, JavaScript invented to do forms validation without a page reload? Wasn't that kind of the one use case for JavaScript back in the days, right? So data validation is a super old topic, but I mean, there are in my book there are two rules for secure web applications. One is validate input, right? I know it sounds super trivial, and I mean, since there are only two rules, it has to be generic, but validating input is key. If you can validate an input, I mean, validating, say, an email address works to some degree, right? But I mean, still, it's tricky. Validating, I don't know, a birth date, okay, that's doable. Validating the contents of a free text input field, like do you have a comment on today's show? Validating is difficult here, right? I mean, what is valid, what is invalid? So one advice I hear a lot is, okay, don't validate input, filter input. Look for specific special characters or specific patterns that you then remove. Typical pattern would be angle brackets, because that might be used to inject HTML or JavaScript, right? But if the contents of that free text field, if the contents are saved in a database, the database doesn't really care about those angle brackets. But if the angle brackets are removed, the database receives incomplete data. So I'm not super convinced about filtering inputs. I'd rather validate it where this is possible. And going back to that free-form text input that's now in the database, when does the catastrophe occur? It occurs when the data is pulled from the database and put verbatim on a website, because then maybe now JavaScript code, malicious JavaScript code, is part of the website. That brings me to rule number 2, filter output. So before you output anything, sorry, not filter output. Now I made the same mistake. Oh, apologies. I ruined my point. So rule number 2, sorry, is escape output, right? So when outputting something, escape special characters. That's true for HTML. That helps prevent cross-site scripting. That's true for SQL, because it might prevent SQL injection. It's true for CSV, because it can prevent CSV injection and more, right? And so that's one of those aspects. Use validation wherever possible. And of course, I mean, for authentication, authorization, we have everything we need in our stack, right? It's there. Basically, restricting access to one endpoint is one attribute in most cases, plus configuration, right? So just use the features that are there. And in auditing ASP.NET Core applications specifically, the broken access, if I find something in the broken access code category, I mean, an audit doesn't really use the OWASP top 10 in that order, but is more thread based first, and then there's more of a holistic second step where you look at the application in general. But when I find something that could be counted as broken access control, usually it's not authentication authorization, because that is pretty stable. There are some other surprising ones. Actually, if you don't mind, I brought an old version of Visual Studio where I just scaffolded a little CRUD application. Are you happy to have a look at that? So
Yeah.
I think I have that application already here. So, I mean, if you've worked with MVC, you probably have seen this before, right? So we can do hello world, and then, I don't know, not very creative. So I hit create, and then if all goes well, we see hello world. And then according to my local specifics, so where I'm at, it's a day, month, year. That's basically the entry we have. So how did I implement that? Because I already said I scaffolded something. So what did I do? Actually, I have a model class here, right? Nothing special, right? I have a title, a text, and a date. And in the class constructor, I set the date to the current date. So basically, date is the creation date. I was just calling it date for sake of simplicity. And then I use the built-in scaffolder of Visual Studio and said, okay, please provide me CRUD. I want controller, I want views using Entity Framework, right? So that I don't have to do a thing because I'm lazy. So I got this create block entry, and I did this, as I mentioned, with the .NET Framework-based ASP.NET. So I was using, just for fun of it, I was using the old ASPX view engine. But I mean, would be the same with Razor, right? But I wanted to deliberately make it look old. And yes, I know there was this date field here, right? And I commented it out, right? Because I don't want the users to provide the date. I just want to provide title and text. The date, as we just saw, comes automatically. And in the controller, the creates a block entry action method receives something of type block entry. That's ASP.NET Core, or back then ASP.NET model binding, right? So we take everything in the HTTP request, and what public properties do we have? Title and text. So if a post field is called title, we set the title property of that block entry instance. If there is an HTTP value called text, we set the text property of the block entry instance. And when we create the block entry instance, we set the date. But of course, since date is also a public property and we're using model binding, I could also send something called date, right? And then this value would be bound to that instance. Actually, let's try that out. Now, I was kind of cheating, but of course that's for the sake of demonstration here. It's unrelated to the actual exploitability. So you remember that there was here we have this commented out thing. And of course, I must not see this as an end user, right? But I left it in because that's no, I don't want to duplicate it. Sorry for that. I want to edit it as HTML. Basically, the UI is back in. And now I can also easily send a date. Of course, even without that cheating here, I could just guess that the property of that field is called date, and attributes might hint me at that, right? And therefore, I could craft an HTTP request. But this makes it just easy. So how about hello world from the future? And as a date, I said, day, month, day. Let's just use November 11th of 2023. Let's try that out. And indeed, now I've created a block entry from the future, and the inspiration for that quick example here was GitHub. GitHub was or is programmed in, I believe, Ruby on Rails, right? But they also have this model binding approach. I think it's called Active Record there, but same thing. And they had the same issue. So for a while, you could create issues that were not opened yesterday or a few hours ago, but 1,000 years in the future. And that's mass assignment or overposting. And if you look at it, I mean, we didn't really validate the data coming in. We allowed access to the functionality if you want that you can set to a date in the future. So basically, it's also in the broken access control bucket. It's called mass assignment or overposting. And the reason why I was using an old version of Visual Studio was in a new version of Visual Studio, it would work as well. But if you're using the scaffolding, you will not only get the code similar to what I've shown you, but also a 2-line comment that basically says, be careful about mass assignment or overposting. So either use an allow list, which properties can be bound with the include attribute, or a deny list with the exclude attribute. So you can either say, okay, only allow binding to title or text, or bind to anything but not to date. And yes, of course, even better would arguably be a view model, because the view only has 2 fields, right? So why should I have a model with 3 properties? But this just shows you that even though it's such a generic term, there are so many different types of attacks that are going on there, and that would be possible, and threats, and therefore it's just awareness. I mean, mass assignment is the idea. I mean, I love the idea, but still the attack is, I think, over 10 years old, right? But still, it's a little bit under the radar. But just if you have this security awareness that, okay, any data you get could be more or less than expected, if you have that in your mind, then hopefully you, even without knowing about mass assignment or overposting, come to the conclusion, wait a minute, I can bind to anything here. The HTTP request could contain more than title and text. I should be prepared for that.
So it sounds like if I use the scaffolding feature in the newer version of Visual Studio, I'm good to go. But if I go off and do my own thing, then I'm kind of on my own, and I could be at risk of something like what you just demonstrated.
Absolutely. So always be aware with every endpoint you have. You get, I mean, a typical mistake I see. And again, apologies for this sounding super trivial or even being super trivial, right? So a typical pattern I see is someone has a drop-down list, like choose your country, right? And then there are 10 items. And then sometimes the backend has the assumption it will be one of those 10. It will not. It's an HTTP request. I can do an HTTP request with telnet, right? So always be aware you could get more or less or something not which you didn't foresee, and just be paranoid, right? I hate paranoia, but in web app security, I can accept it.
I think that's a good point too, because I've seen a lot of websites that drop-down list would bind to the full model and just tell it to use these 2 fields, as opposed to just recognizing in the view we only need to deal with these 2 fields. And it's a good argument for tools like when people ask me why GraphQL is popular. That's a tool that specifically allows you to shape the data based on the use case, as opposed to having this potential to overpost data that you don't want. But I wanted to point out 2 things that I got from what you were saying. One of them is that we think of security, we're thinking of authorized attributes and .NET identity and everything else. But what you're saying is, let's get back to fundamentals, and even internal to the application, regardless of how it's exposed, objects should make sure that the data that they're taking in is the right data, so it should be validated coming in and out. And the other thing I think is that testing becomes so much more important, to test down that route of testing the unexpected. It's so easy to write the test for the flows I know, like, let's do a title that's too long. But do people actually write tests to throw like Unicode characters or escape characters or HTML tags and go that extra mile? So it's good feedback.
By the way, sorry if I may interrupt quickly, but since you mentioned GraphQL, yes, absolutely. So and you pointed out one of the reasons for using that. But even with GraphQL, you have to be aware of the possibilities you have, right? So for instance, you can say with GraphQL the page size, right? So how many items should be returned? That's depending on configuration, of course. That can be part of the request. So someone could send a request and say, yeah, just return 1 million items, which might kind of be denial of service then, technically, right?
Yeah, I think the takeaway for me here is expect the unexpected. As our friend David Pine points out in the chat, never trust the client.
Absolutely.
I 100% agree with that statement. Also, shout out to Cam, who is experiencing other security related issues. He's set his smoker on fire again.
Again.
You may want to drop the show and take care of that. Cool. So I'm wondering, you just showed us a wonderful demo in Visual Studio. Are there any other demos you could show us for any concepts represented in this OWASP list?
There are different things. Maybe actually I have two in mind. Let's maybe quickly talk about our two. So one thing, and I want to specifically point that out because it looks like an oversight looking at that list. Wait a minute, where is cross-site scripting? Yeah, I know cross-site scripting is a weird term, right? I think a better name would be HTML and JavaScript injection or something like that, because that's what it is. But where is it in that list? And for a long time, many people have said, yeah, cross-site scripting is not that dangerous anymore, and that led to and again, my personal opinion here, right? Led to the situation that the number one item on the OWASP top 10 was SQL injection. And I said, I mean, and that's probably because of the stack, I'm using or we are using. We have the knowledge of protecting against SQL injection, and also when using an OR mapper, it just gets less likely to catch SQL injection. But supposedly, in other technologies, there was still so much SQL injection that it still was number one. Now, based on the data-driven approach for that list, SQL injection would have been, I think, at the number 10 or 12 spot. And I mean, the bucket is called injection because there are other injections as well, like XPath injection, CSV injection, but still. So it would have almost fallen out of that list. And now it's on the number 3 spot. What happened? Because that other risk or attack that is supposedly not that relevant was added to the category. Cross-site scripting is now part of number 3 injection. Now this sounds, how do I phrase this politely? This sounds really weird, right? Technically, it's not entirely wrong because cross-site scripting is injection. You inject usually JavaScript into usually HTML or in an HTTP response of HTML, right? Still, I would have wished they had renamed that category, right? One thing I'm super psyched about when it comes to cross-site scripting, because cross-site scripting still is probably the attack I find the most when doing an audit. Because actually, I don't know why. Because we have built-in countermeasures against cross-site scripting in our stack, right? So, for instance, if we look at, say, I have an example here. Oh yeah, I have one. So typical. So that's like the hello world of cross-site scripting. You don't even have to run it in a browser, right? You have a search field here, and then after you submit the form, then the search is run. So usually whatever database is queried or some service, and then the result is printed. And here you see that I'm using @html.raw, which in most code bases you see rarely. What does html.raw do? It outputs something verbatim. And of course, if the result contains, say, JavaScript, then the JavaScript would now be part of the page and we would have cross-site scripting. But HTML raw is only there because I put it. And if you taught someone ASP.NET Core MVC or Razor Pages, and you would completely skip the security block, which of course I would never ever recommend, but it happens so often, then they would write code like this. Use the character and then I output a value. This does HTML encoding. So this automatically HTML encodes. HTML encode as in the old ASP classic server.html encode method. The method still exists. It's now in HTTP utility, but basically that's the same as before, and that just works out of the box, right? So again, even if someone has no clue about cross-site scripting, when they just output data with that character, they are relatively safe. I say relatively safe because, just as a bad counterexample, here I have some convoluted code where I still get a result, but I write the result in a JavaScript variable and then output it on the page, right? And I do this intentionally. It looks weird, but it kind of mimics a mixture of a regular web application, a single page app. And I want to point out one important aspect here. It's actually we could run this. So when we go back and I think, yeah, there should be here search page. So if I search for something, right, and then I get, okay, your search didn't yield any results. But now I try to be clever and I try to do cross-site scripting, right? So this is really super basic cross-site scripting. But it doesn't work. Why doesn't it work? Because that is not put into the HTML verbatim so that the browser could pick that up and parse this as JavaScript. No, instead it's just there as text. And if we look at the source code, basically you see that the angle brackets, they have been, rule number 2, escaped before outputting, and thus no cross-site scripting, right? And the problem here is HTML escaping does exactly what the name says. It escapes HTML characters. So if we are in an HTML context, we are good. But we are not in an HTML context, right? This is another context, JavaScript string. There's a special character in a JavaScript string. Okay, tough question. No, of course, there are many or several, put that way, but one of them is the backslash. And one of the things you can do in JavaScript with a backslash is you can start escape sequences. I mean, there's stuff like \n, \r, but you could also use something like \u for Unicode characters or \x for characters with the hex char code. So you can use char codes instead of maybe forbidden characters. Now it's getting interesting. I happen to know the hex char code for the opening angle bracket. That's 3C. And the one for the closing should be 3E. So 3C opening and 3E closing angle bracket. Now, when this is put into the JavaScript string, this escape sequence here represents an angle bracket, but of course it's not escaped. The add character does not escape the backslash because the backslash is not an HTML special character. And so in the end, we get cross-site scripting, right? Although we have the protection. And this is basically the idea here, right? So in 98% of cases, everything goes well, right? But then sometimes it does not go well. And one of the things I really dig, and I think that is an extra layer to web application security, is something called, actually, let's open this up. It's something called content security policy. So I'm linking to the World Wide Web Consortium. They are currently working on standardizing version 3 of that. So you see that last month, there was the last update to the document. Content security policy version or level 2 is the one that is supported by all major browsers. Level 3 only by Chrome-based ones. And that is an extra layer of security, that lets the server send a so-called policy to the client, instructing the client, okay, you can only load resources from here and there and there. And among other things, you restrict where to load JavaScript from. So when, say, someone exploits a cross-site scripting vulnerability in your application and injects script src equals http mybadattackerserver.com/malicious script.js, that server is not on the allow list. So even though there is an exploitable cross-site scripting in your application, it cannot be really exploited that way, because you can't load JavaScript from arbitrary domain unless the content security policy allows it. It also restricts inline code. And I mean, I could talk for an hour about that topic, but the idea is you basically restrict the browser to only being allowed to do certain things to load certain resources. It's a defense in depth mechanism, so it's an extra layer of security. It's no excuse for not preventing cross-site scripting in your application, but it is a great tool. And so I can only encourage everyone to start new projects with a content security policy in place. For older projects, there might be some work involved, right? Because depending on how those projects were set up, say a lot of inline JavaScript code, you might need to refactor the applications or have a bit more work in creating that policy. But this makes me super confident that cross-site scripting will decline in popularity, as long as you can talk about popularity within the tag, of course, and therefore that maybe that injection and cross-site scripting item in the list is dropping down the list. Once the next list is released, and that should be in 2024, 2025.
Christian, I wanted to go back to the demo that you were sharing where you were describing the raw HTML helper, and you had a Razor view up.
Yeah.
We had a question from one of our viewers that I want to get addressed here.
Absolutely.
And so you were using the example of a script tags. What if we used the code HTML element instead? What would we expect to happen in that case?
The code HTML element still has an HTML context. So if you wanted to no, actually, in the wait, no, not that I say something incorrect here. The code HTML element outputs the contents verbatim. It's or basically as text. I think line breaks are retained, right? Is that correct? In that case, since it's only text, there wouldn't be I wouldn't see any cross-site scripting vulnerability.
Unless you were able to close the code block in the text that you provided it, and then start a new line.
That would be correct. That would be correct. But yeah, that would be correct. So if you close the code tag, then you are back in HTML context, not in code tag context. In HTML context, you would then have the special character issue again. Yeah, so that would in that case it would pose a problem, because then when you output something, what you basically need to get rid of is the closing code tag, and there can be many variations: lowercase, uppercase, mixed case, maybe a null byte in between them, right? So maybe just using CSS to style it and outputs the code with the regular add character, thus escaping the HTML special characters, and then maybe just replacing the line breaks with BR tags or something. Maybe that would be a safer approach, just top of my head.
And then so again, going back to this example, is there any risk with, say, the style tag if I were to use that?
Yes and no. In I think IE7, you could run JavaScript code via styles. There was the expression, I don't know what it was called, filter or something in CSS, and that expected JavaScript code, so you can run JavaScript code. Of course, this is different now. CSS3 has calc, but calc has a specific syntax, so calc doesn't accept random JavaScript code. And there's an ongoing debate, especially when trying to apply a content security policy, as I just described. We have to get rid of all inline JavaScript. That's obvious, right? Because inline JavaScript is also, as shown here, a cross-site scripting attack, or can be one. What about inline CSS? Especially legacy applications often have a lot of inline CSS. We can't just easily get rid of that. So if you have a content security policy, we could say, okay, inline CSS is okay. So can JavaScript code be injected that way? No, not to my knowledge. Can some other bad things happen when CSS is injected, or where some styles are injected? Again, yes and no. Of course, you can add some, depending on the scenario, of course, but you could add some classes that some things would not be visible, would be outside of reach, right? So some unnice things still might happen here. One scenario that is commonly used as the reason to, if at all possible, disallow inline styles is you could create an inline style. So where basically say if you have a password field on the page, you can have a CSS3 selector which says the content of the password field starts with an A. And you can have the contents of the password field starts with a B, etc., etc., etc. And then you could apply a style to that selector. The style would be the background image of that password field is the following graphics: http attackerserver.com / data collector / A / data collector / B, etc. So kind of like a keylogger. Yes, I accept that, but this would require that the application is allowed to load images or resources from attackerserver.com. And if you have a content security policy in place, I would argue maybe we actually do not allow that. So as always, it depends, but it's in my book, it's less critical than cross-site scripting.
Yeah, I wanted to add just really quickly too that the fonts and images both have shown known attack vectors. With the fonts, it can exploit known driver issues. So having the integrity tag on that, so you know it's the font you want, and using the CSP is key for that.
Yeah. Oh, integrity is a great feature. So I happen to have the Bootstrap page up, and when you look at the instructions, and I mean other frameworks have that as well, right? So you see that when you include Bootstrap or others, you can use something called sub-resource integrity. That's what Jeremy was referring to. So we have an integrity attribute in HTML, and that basically contains the hash SHA-256.384.512 of the file, right? So if then someone takes over the server from which you're loading content, that malicious content will most certainly have a different hash, and thus that can also help against whatever third-party servers you rely on being taken over by someone, and then they throw malicious code at you. Thank you for mentioning that. That's also super important, I would say. And it might fit into security misconfiguration, because it's a security feature you have to configure more or less, right? And same goes for all of these HTTP headers. Content security policy is an HTTP header, so not having it could count as security misconfiguration because you are missing an important header. But well, it's also prevents number 3 injection cross-site scripting.
So really quickly here, you mentioned how some of these top 10, they are informed by audits that happen and they tend to be sort of backward looking. And you also mentioned that there are sort of some forward looking ways that these considerations and guidance is compiled, right? And so when we look at the forward looking aspects of it, what sort of, is there any guidance in AI and sort of the sort of considerations, risks that from a security perspective that may bring into your applications?
I mean, indeed, many applications are successfully exploited by tools that just automatically try to exploit common vulnerabilities. And I mean, these tools, maybe they are not an artificial intelligence, so an AI, but often a kind of manual AI or a community effort where many exploits that have been successful in the past are used as payloads against target sites. And I mean, there's not that much difference between a security scanner for good and a security scanner for bad, right? And I think that not necessarily AI, but maybe indeed some learning from past exploits might be helpful. Not only in finding vulnerabilities yourself, basically in finding vulnerabilities yourself, and of course the other side then has the same capabilities of finding vulnerabilities in your code. I was recently discussing at a conference whether the help of AI would make web application firewalls more usable. So a web application firewall is kind of like a piece of software that looks at the incoming HTTP requests and then tries to find out whether that request basically is an attack or not. And again, problem here is false positives, right? So I once had an overzealous web application firewall that was checking the password field. so it was not the fault of the firewall, it was the fault of the configuration the company did, and they disallowed spaces in the password field. And if you follow that famous X key CD comic, what you do have in your password fields are spaces, right? So that was a bit of a weird thing, but maybe I mean the key for web application firewalls and also for security scanners is the rule set, right? And maybe a rule set that is maybe artificially or maybe curated, that is just made better based on experiences, can only make the situation for everyone better. Will there be an AI soon that will break into applications, exploit it, and then write the ransomware email themselves? I'm not too sure yet, but that could be famous last words, right?
So we have another question from one of our viewers, and this goes back to the content security policy topic.
Yes.
And if I display this question up on the screen, it's asking, how will these content security policy resource allow lists impact ad services?
Yeah, it will. What is not on the allow list will not be loaded. I mean, depends a little bit on the ad server. For many ad servers, they themselves host the ad content. So what you need to put on the allow list is the ad server. Same goes for tracking services or analytics services, right? So they also have a set of servers data is loaded from. And I mean the challenge when implementing a content security policy is actually assembling and compiling a list of which resources your application is loading, right? And by the way, that's, in my opinion, super important to know anyway, right? That you know what your application is doing. And therefore, even if you have ad services in, I would be pretty sure that there is a limited list of domains or URLs, or at least base URLs for those ads and where they are coming from. And so they need to be put on the list. All of the ad providers are, of course, aware of content security policy and make or aim to make their solutions content security policy compatible, right? Because content security policy is gaining traction a lot, and again, it's probably the best weapon against cross-site scripting we've had in a long time. There's another one coming up. It's called the Trusted Types API, but it doesn't have support in all major browsers yet. But basically, this also restricts what JavaScript is allowed to do, not just which JavaScript is allowed to run, but when the JavaScript code is taking data and it is putting it on in the page's DOM as something like HTML. So for instance, setting inner HTML, that can be restricted by that, so that the code may not just put arbitrary strings into inner HTML, but only select data. So there is some movement there. It's sad on one hand because it just shows that we as developers do not seem to be competent enough to solve this on our own. But on the other hand, it's great because we have now a very effective tool against ubiquitous cross-site scripting.
Yeah, I would say too with the cross-site, with the CSP policy, it's very eye-opening too. If you are using an ad provider, I was able to filter out a lot of ad providers because I expose calls to sites that I didn't want them making calls to. And so, if they provide a published list of secure domains that they use and serve their own ads, it's one thing. But if they're just including their own third-party code and it's the Wild West, then you're opening yourself up to a can of worms. So CSP, I cannot recommend it more. It's super helpful.
Yeah, I agree.
Now, if I wanted to set up a content security policy, viewers may be wondering at what level in the application is that configured? Is this at the web server level or somewhere else?
I prefer it on the web server level because then it's always there, even when no new content is added to the application. But of course, it could be that there is this one page that is pulling in data from all kinds of sources, and it's the only page in the app that does that. And I would like to have my content security policy as strict as possible. Therefore, in those cases, maybe I would make a specific content policy for that page only. What I should maybe add, if I have the time, the content security policy comes with a reporting feature. So basically, when you have a policy violation, then the browser can automatically send an HTTP post request with some JSON data about that policy violation, which policy, which file, which line, depending on the browser and configuration, code excerpt, right? So you can have an endpoint that gets all of these policy violations. And there are only two reasons for a policy violation. One is you have a mistake in your policy, so you forgot your ad provider's server. And the other reason is that you have a cross-site scripting vulnerability that is actively exploited. Both are things I think you want to know and to fix. And you can put content security policy also in a what-if mode. In the what-if mode, all policy violations will be reported, but the policy will not be enforced, right? So you can test out the policy on the production system, basically, and then see how well it works, and then eventually switch. For a new project, of course, you start with a content security policy anyway, and therefore you know that your application works with a content security policy from the very start.
So I just want to see the ability to set that endpoint to ChatGPT and then ask a couple weeks later, all right, what's the recommended CSP? Give it back to me now.
Oh, absolutely. And I mean, there are also the tools or demos where basically you take those reports and then assemble a list of resources. That alone is helpful already, right?
Good stuff. So we've got 2 minutes remaining in the show. To wrap things up here, I know you've shared the OWASP top 10 list. Are there any other resources viewers might be interested in?
The security documentation in the ASP.NET Core documentation is pretty good. It also goes into much more details on some other aspects which we couldn't cover, and of course in the specific APIs that help prevent these attacks or help mitigate those attacks, right? So they are always the go-to place, because I think that's a very, very useful resource. Also, the OWASP top 10 has, of course, more details on those attacks, and OWASP also has cheat sheets, as I call them. So how to prevent this attack and that technology. They're not always 100% up to date, depending on the stack, right? So sometimes the horse's mouth, meaning the documentation, is a great thing. And yeah, of course, I also wrote a great book on ASP.NET Core security, but actually the information publicly available should also bring you pretty far, unless you would like some in-depth coverage.
All right, folks. Well, unfortunately, that's all the time we have for today's show. I'd like to give a big shout out to Christian for sharing his expertise with us today, and also to our viewers for tuning in and sharing the last hour of your day with us. As a reminder, you can check out other great .NET Live TV streams like this one over at dot.net/live. Next week, I hope you all tune in again. We'll be joined by guest Denny DeClercq, who will join to talk about building accessible Blazor apps. See everyone next week. Thank you.
Thanks for joining.